This conference will now be recorded.
Yeah, good morning to everyone. So in the last session, we started the interrupt controller, design file of the interrupt controller, right? And we run the two test cases. One is nothing but so the two test cases is. What are the two test cases we ran in the last session? We close the loop. Okay, let us repeat this once again. Interrupt controller design file, and then today we'll go to the different test cases of the interrupt controller. I think understanding models of the processor, EBP, right? These things are clear. What is the clock reset common signals and some control signals, and there is a data signals like W data, write data, and the read data. And then what are the signals to the interrupt controller we are using is, what is this defines? Interrupt active is nothing but what? Number of interrupts. Number of interrupts coming from the way peripherals. And what is this interrupt valid 0 is? It is telling that if interrupt valid is equal to 1, so these are the valid interrupts. To the processor should answer to all these valid interrupts. If valid is equal to 1. Saying valid is equal to 0, what happens? No valid interrupts. Correct. Then interrupts to be serviced is the output to the interrupt controller. So this is the questions is giving to the what? Processor. Correct. Interrupt to be serviced. So this is output for the interrupt controller. This is a signal where it gives the what? Questions, interrupts to the processor. How do you understand? This is interrupt to service is once processor addressing all the interrupts, here indicating the signal with interrupt service is equal to 1, saying that I have answered this questions. You can understand. So this is these four signals are very important to understanding the interrupt controller. This defines the number of interrupts. This is nothing but to check whether valid interrupts or not. This is nothing but questions or interrupts are giving to the processor. And then this is nothing but once a processor addressing the interrupts, giving the signal to the interrupt controller. After this, we have defined the depth. Here, I'm using the depth is nothing but number of interrupts it is. Depth is nothing but number of interrupts, or you can use number of interrupts also, nothing to worry. Okay, depth is number of interrupts. Then I'm calculating the width based upon this depth. I'm using $C log based of the depth. So this gives me the result of what? If there are 16 interrupts are there, the width I'm getting is what? 4. So why I do need this width is nothing but, now when I'm modeling the parity register, the index of this parity register to index of that is defined by the what? Width. You understand? Then we are defining this parameter with the states. So there are 3 states we are using, right? Now coming to this, the 3 states are, one is state with no interrupt, means it is not getting any interrupts. If there is no interrupts, that is means interrupt active is nothing but what? Interrupt active is nothing but, this is nothing but interrupts, right? If this is equal to 0, it will stay remains the same state. If there are interrupts are there, how to write the condition for this? Not is equal to 0, correct? Not is equal to 0 indicates that there are interrupts. Are you understand? If there are interrupts, I'm going to the what state? Next state. Did you understand? If there are interrupts, what I need to do? If there are interrupts are there, in the priority register, correct? Priority register is modeling by the processor. Once that is modeled, what we need to do? These interrupts are kept or stored in the parity register according to the what? Parity. According to the parity. So we need to keep in the register. Now this is what? This is a state with the active interrupt. This active interrupt, we are finding the highest parity interrupt, and then making the interrupt valid is equal to 1. So we will be making the interrupt valid is equal to 1. And then giving the highest parity peripherals to the what? Processor. So this is state, it do 3 things here. Finding all the highest parity interrupt, then making the valid is equal to 1, interrupt valid is equal to 1, giving the highest parity peripheral to the processor. So once it is giving to the processor, what is the job of this state is? What is the job of this state is nothing but, after finding the highest parity peripheral, which state it is going to go? It is moved to the next state. Next state I am writing as a state with the service is done. Or I can write, I have given the interrupts, waiting for the what? Service. Waiting for the service. Did you understand? Now in this state, what I can do? The service is done state, what I need to do? I will make the interrupt valid is equal to 1. 0. Then highest parity peripheral is equal to 0 means, this indicates that peripheral 0 means what? I have answered, means all the interrupts is addressed. Then valid of making 0 is nothing but what? This is what? Valid is equal to 0. I have whatever the questions you have given to me. When valid is equal to 1, our interrupts are addressed. So that this indicates highest peripheral is equal to 0 indicates I have answered the addressing all the interrupts. Once we've done this, what I need to do? Again, I need to check if any interrupts are there. Interrupts are there. If there are no interrupts, it is going to what state? No interrupts state. If there are interrupts, again I need to repeat this, right? Again, we make them into the what? Highest parity, we need to find out the highest parity interrupt, making valid is equal to 1. Then give this parity, highest parity peripheral to the what? Processor, and wait for the what? So interrupt given, waiting for the what? Service. Did you understand? The same thing we correlated with the program. Same thing we transform into this into what? Program. So how many states are there? 3 states are there. The 3 states we defined here with the 1 not encoding. One state is state with no interrupt, state with active interrupt, state with service is done. Did you understand? Now after this, what we did for all the input signals of the processor, declaring with the input and output declaration. And if there is a vector, so we are declaring with the vector. P address, W data is a width minus 1. And then P, R data is nothing but width minus 1. So literally, this is not at all required. what is our intention of this interrupt controller is? What is the intention of the interrupt controller? First, we should to model the parity register in the interrupt controller. Then, what the interrupt controller will do? It will collect the interrupts coming from the peripheral. It will put according to the what? Parity. Then, once you starting according to the parity, that will be given to the what? Processor. It's saying valid is equal to 1. And then waiting for to be service. That is what exactly we are modeling here. So that we need this R data. R data is not required. First, you are modeling addressing. Each addresses you are keeping the what? You are writing the data. Once you write the data, we are keeping according to the parity. Then that will be giving to the what? Process. So since we are talking about the memory modeling, so we are declaring this signal R data. Are you understand? Then these are the interrupt controller signals. So first interrupt controller signal is nothing but active interrupt. Active interrupt is nothing but one number of interrupts. What is the number of interrupts is nothing but vector is depth minus. If there are 16 interrupts, are there 16 minus 1 is 50 down to 0 is 16 interrupts. Then this is nothing but a input with a single scalar. So this is a interrupt service is nothing but what? What it indicates. Once the processor addressing all the interrupts, it is giving signal that one saying that now I have answered all the questions or interrupts. I have addressed all the interrupts. Correct? Now what is this is nothing but interrupt valid. So only when valid is equal to 1 only we'll give the valid interrupts to the processor. And then this is nothing but what? Interrupt to be serviced is nothing but what? That is interrupts, which is stored in the where priority register is giving to the what? Processor. So what is the width this is? What is the width this is? So what is the vector? This is nothing but width minus 1. This is stored where this is stored here. Where this is stored? It to be serviced in the priority register by taking that what? Index of that register. Those interrupts are giving to the what? Processor. So that this is defined as output signal. Correct? If I want to make the memory means here we'll talk about the register. So this is nothing but array of what? Vector. Priority register. So what is the depth is nothing but 16. Means why it is 16? Number of interrupts. Number of interrupts are 16. To keep that, what I need? Address index. Address index width is nothing but how much? Width is nothing but 4. We are calculating the 4. 4 minus 1 is nothing but 3. 3 down to 0 is nothing but 4. 0, 0, 0, 0 to up to 1, 1, 1, 1. Did you understand this? Then what we are doing is, so we need a states with the present state and the next state. So this is 1 not encoding we are using with the 3 bits. So that it is 2 down to 0 of state comma next state. And then we are using 2 variables. These 2 variables are used to find out the highest parity value and then highest parity peripheral. So what is the vector of this is nothing but width minus 1 down to 0, and this is also width minus down to 0. Did you understand? And then what are the variables which we are using in the program? We declared it. One variable is flat, one variable is I. Now this is completely a program from year to year. This is completely a program for memory modeling. Correct? Up to here it is nothing but memory modeling. If reset is equal to always at the positive edge of the clock or positive edge of the preset is equal to 1, we are making all the reg data types to 1. Zeros. So along with this reg data types are zeros. This flag is also 0. Then this reg data types are 0. Since this is an array of vector, so that I need a for loop. For I is equal to 0, I is less than depth, this parity register is assigned to 1, 0. Since it is an array of vector. Okay. And this interrupt to be serviced also initially, reg data type, we are making 0. And the interrupt valid is also 0. Ready is equal to 0. PR data is also 0. All the reg data types are making 0 here. When reset is equal to 1. Or you understand? When reset is equal to 0, what I have to do? Now I have to do the memory read and write operation. If reset is equal to 0, this else tells that reset is equal to 0. When reset is equal to 0, how you can do the memory write and read operation? Handshake. So what is the control signals we are using for the handshaking in this ABPs? One is P enable and then P read. If my P enable is equal to 1, now ready is equal to 1, then I can start the what? Transactions will be started. But what I need to do here, I should tell that when to do the read and when to do the write operation. That will defined by what? P write. If my P write is equal to 1, so what we are doing is nothing but write operation. For your parity register, this is nothing but address, parity register. I am doing the what? Write data. You understand? Else, if my P write is equal to 0, what I am doing? Read the data. Actually, we are not using this part of this program in our program. When you are doing the interrupt control, correct? We'll write the data. After writing the data to the parity register, we are keeping what? According to the parity. Then we'll do concentrating on the what? Parity interrupt controller operation. Are you understand? Since this is a memory kind of memory modeling, so that we'll do this part of program also. Are you clear? Now, if enable is equal to 0, this enable is equal to 1, we are doing these things. Read and write. When the write enable is equal to 1, write operation. Write enable is equal to 0, or write is equal to 1, write operation. Write is equal to 0, read operation. If enable is equal to 0, when enable is equal to 0, there is no handshake. So that I am making what? Period is equal to 0. You understand? Then we'll end all this if and else if and always plug. Did you understand this? This is a memory modeling. Now, once you design the priority register, when you do after declaring the priority register, then the read and write operation, then comes the job of what? Interrupt controller operation. In the interrupt controller operation, can you recall what is the operation of this is? Collect the interrupt from the peripherals, keep according to the priority, and give the highest priority according to the highest priority, give the interrupts to the what? Processor. So wait for the service, waiting for the service. Correct. Then processor takes the what? Interrupts from the interrupt controller and address to the peripherals, then giving the signal to the what? Interrupt controller. Did you understand? Now what we are doing is, you can recall this diagram, state diagram. There are three states. One state is nothing but state with no interrupt, state with what? Active interrupt, and the state with service is done. State is service is done. So in the state with the no interrupt, so this has to done when reset is equal to I or reset is equal to 0. Same clock, right? It should be same clock, so that I'm using always at the constant of the clock. If my reset is equal to 0, reset is equal to 0, then there are states are there. So that I'm defining the what? Case state. If first state is this is operation, then second state and so on. In the case statement, what is the first state is? State with no interrupt. The state with no interrupt, what is the operation here? Interrupt. Active interrupts are 0, you remains in the same state. If there are interrupts are there, go to the next state. Go to the next state. This is what if interrupt active in this state, if interrupt active I not is equal to 0, what this statement defines? There are interrupts. There are interrupts, right? If there are interrupts, means this is true. When this is true, which state I'm going? Going to the next state means state with active interrupt. Let me tell you what is why I'm using flag here. For the moment, we'll understand this. What I'm writing the state diagram here. Okay. Then else where I'm going? Else in the next state is nothing but what same state. If there are no interrupts, I'll be staying in the same state. Are you understand? Now this is a state one. State one. Now coming to the state two. Coming to the state two. In the state two, what I have to do? There are interrupts are there. I need to find out the highest priority interrupt. Then I should make value is equal to 1. Give this highest priority interrupts to the what? Processor. This is the one I'm doing in what state? In the state two. State with the active. Now coming to this one. So in the second state, state with the active interrupt. Now let us take an example. Yesterday I was talking about this one. Let us take this one to refer this document to understand how this will be, how you are making the, once you get the interrupts, how you are making it according to the priority. Okay. So this is my peripheral names. How many peripherals are there? 16 peripherals, 0 to 15. Correct? There are 16 questions are there. Means 16 peripherals. This is the name of the peripheral I'm writing like 0, 1, 2, 3, 4 up to so on 15. Then peripheral values means what? Priority values. So I'm taking random. These are unique random values. What is the unique random values? Unique random values. There is no number is repeated here, right? It falls between 0 to 15. Correct, 0 to 15. That is nothing but unique random value. So 10, 2, 5, 4, 6, 8, 9, 15, 1, 3, 12, 14, 11, 9, 7, 0. So it lies between 0 to 15. 0 to 15. Unique random value. No number, no parity value is not repetitive. How do you understand? Is it clear? Now what I need to do in this state? Find out which is the highest parity. To find out which is the highest parity, we need to check with the what? Interrupt raised. What is mean by interrupt raised is was raised the hand and was having a question. Correct? Are you understand? So someone is raising the hand, but there is no question. The student one is raising the hand and there is a question. This one indicates we need to this is an interrupt we need to address. You don't understand? Like this, what are the interrupts we need to address here? What the interrupt is raised here? You tell me with respect to the peripheral name. 1, 4, 8. 8 is not there, sorry. Is it 9 is there? Yeah. 9 is 1 is there. Yes. Then 11 1 is there. Yes. Then 13, 15. So these interrupt names we need to address. We need to processor should address. But to do the address, first we need to make this into one according to the priority. So what is this 0 indicates? Interrupt is not raised. So this 0 indicates interrupt is not raised. How to understand? Now what we'll do after service interrupting goes low means you taking the interrupt according to the priority, you are giving the service to that. So that what I need to do after giving the service to that is nothing but I should make this to what? Interrupt rise making to what? Low. To 0. Answered means it is addressed. So how to do this? How to do this? First, I want to make according to the parity. And I mean, like we talked about ascending or descending it is. Ascending means descending. Highest to the lowest. Highest to the lowest. How to do this? Highest to the lowest. First, who is raised the what? Who is raised the interrupt rise, we will taking this as a reference. We'll take this as a reference. Now what we are doing, this is a 2 is the interrupt value. 2 is the interrupt value. So we are making flag to 1 here. Flag to 1. First we are comparing this with this, whether I need to compare this with this. No, why? Interrupt is not raised. Now this I should compare to what? 6. This I need to compare with the 6. If I'm comparing, how I'm comparing here? Let us come into this program first. Now what we are doing is nothing but this is for what? For loop is for what? 0 to 60. 0 to 50. Correct. 0 to 50. So I need to go to this 0, 1, 2, 3. So that this is my number of interrupts. I should go to 0, 1 to up to 150. I'm taking the for loop. Now what I need to do? What is this condition tells the interrupt underscore active underscore I of I is equal to 1 defines what? Interrupt is raised. Correct? This indicates where the interrupt is raised. When interrupt is raised, what we are doing? If flag is equal to 1. Now I'm writing if flag is equal to 1, what I'm doing? IS parity underscore value is equal to what? Priority register of I. What is the priority register of I means? The index value of this priority register, right? What I mean to say, this is the interrupt is raised. First, we are taking interrupt underscore active I of I is equal to. First, it will take I is equal to 0 here. Here I is equal to 0. Whether this is equal to 1? No, right? I is equal to 1. I is equal to 1. Is it yes? Yes. This interrupt is raised. If interrupt is raised, what I'm doing here? I'm checking if flag is equal to 1. If flag is equal to 1. If flag is equal to true, what I'm doing? IS priority value. What is IS priority value is nothing but. Now, as of now, I'm assuming that this is my highest priority value. Correct. I'll go to first, this is my reference. This is a reference for us. Now what I'm doing, highest priority value is now what? 2. Highest priority value is assigning is equal to priority register of what? I. What is the priority register of I is nothing? 2. Now what is the highest register value? It becomes is 2. When if the flag is equal to what? 1. Now this is we are taking the what? We are taking the highest priority values right now. What is the value is 2. This is what we are doing. Now highest priority value is equal to what? 2. What is highest priority peripheral as of now? 1. Now this is nothing but 1. Now I will get the highest priority value is 2. Highest priority value is 2. What is highest priority peripheral is nothing. Now it is 1. You understand? After this, what we are doing? We are making flag. Means this is I'm taking the reference. From this first reference, first value, if I'm find out in what? Priority value and priority highest peripheral. By taking this, then I'm going to start comparing with the other one which you raise the interrupts. Did you understand? Now, currently, what is the value of the highest priority value is 2. What is the highest peripheral is nothing but 1. Then flag is equal to what? We are making flag to 0. That rise at 1 is making to what? 0. Else, if flag is equal to 0, what I am doing? In the else, what I am doing is nothing but highest priority value is less than 1. Priority register of 1. Now, my priority register is 2. Correct. Now, what I am doing here is nothing but I am checking less than or equal to 1. 2 is less than or equal to this. If flag is equal to 0, it goes here, right? Flag is equal to 0, it goes here. Now it goes to where? Here. Now 2 is less than 6. 2 is less than 6. Is it true? If this condition is true, so what I am doing here it is. Highest priority value is equal to what? Priority register of I. What is the priority register of I is now? 6. Now I'm getting the highest priority value is nothing but 6. Then what is highest priority peripheral is 4. It's nothing but this value is nothing but 4. Now this is a 4. Did you understand? So next what happens here? Next what happens? Again it will take 6. Again it goes here. It goes here. Are you understand? It goes here. What it is going to check? 6 is less than 9. If 6 is less than 9, what happens? No, 6 is less than. Now this is 6 is less than 9. I'm getting it here. 6 is less than 9. It is true. If it is true, what happens? Now highest priority value is nothing but what? 9 here. What is this index? Sorry, value or value 3. Value is 3. Sorry, not 9, right? Sorry. 6 is less than 3. 6 is less than 3. Is it true? This is false. Then what happens in this case? Now it becomes what? 6 only. What is this index? Parity index peripheral is 4 only. It is 4 only. Did you understand? Now again, what it is going to do? Again, it will take 6. Again, it will go whose raise the interrupt. Now here 6 is less than or equal to 14. It is true now. Now what is my parity value? 14. What is index value is nothing? 11. Now currently my value is 14. Index is 11. Again, what happens? Again, 14, right? This is 14 less than what? 9. 14 is less than 9. And is this true? False. Correct. What is my value? This is nothing but 14. The index is nothing but 11. Did you understand? Now, what is the next one is? Again, 14 is comparing to what? 0. 15 value is but what? 15 value is 0. 14 is less than 0. Is this condition is true? No. If this condition is no, what is my current value is nothing but 14. What is my interrupt peripheral is 11. Did you understand? Now for this iteration, what is the highest parity? Highest parity peripheral is what? 11. So we need to first need to be serviced to what? 11. How do you understand? Then what I need to do? What I need to do? Which one I need to make it to low? Means flag to 0. Now this is, I understand that this is nothing but by what? Highest parity. Now this flag making to what? 0. This flagging making to what? So that's why I'm making this is to what? 0. You can understand. Now again what I need to do? Again what I need to do? Again I go back here. Again you keep comparing this. Once you keep comparing, what is the next highest priority to be service is? Now this becomes 0. Let us remove this is 0 here. Now let us remove this 0. This 0. Now I'm making this 14 to what? Making to this 1 to what? 0. Because I have this is the first priority I have service. Next what I need to do, you check, you see according to this value, you tell me which one I need to give the service. 13. The value is 9. So 9 is among 9 is greater than this 15. 15 value 0. Then is already done. 8 value, 8 peripheral name is 1. And then 4 peripheral is nothing but 6. Value is 6. And then 1 peripheral value is 2. So that next I need to do the service to the what? 13. 13 index, 13 peripheral name whose value is 9. Now this is 0. Now I'm going to make this 0. Correct? Now this is nothing but 13. Second interrupt to be service is nothing but what? 13. Are you understand? Again, this will repeat, right? Now what I have to do? I should make this to 0. This I will make the 0. Again, I should repeat. Repeat this. Correct? Now you tell me which peripheral name I need to give the service. Interrupt to be services. This is 2. This is 6. And this is 3. 15 term is 0. Which one I need to give? 4. 4. I should make this to what? 0. This flag is making to 0. Now what? This is third one I need to give interrupt to be service. And next what I need to do this 2. 2 is there. Again next is 3 is there. Next is 0 is there. So that 9 value you need to give the what? So which one? This 3. 3 is greater than 2 and 0, right? So that I need to give service to the what? The peripheral name is 9. Now it is a time. You do understand. Now I should make this to what? 0. Make this to 0. Next, what I need to do? 2 is there. Next is what the another value is? 0. So that I need to give what? Is the index to be? This is 9. What is the index service to be? Nothing but value is 2. What is index? I need to give the name is nothing but 1. Now this becomes not 2. This is the 1. Then I need to make this as to what? 0. Or you understand? Then what is the last one is? 15. 15 value is what? 0. So that the last sixth interrupt to be service is nothing but 15. Total how many interrupts are raised at? 6, right? This is 1, 2, 3, 4, 5, and 6. Now I should make this to 1, 0. Did you understand? So this will take the reference value. We'll start comparing. So once you know that which one is highest one, you make that flag to what? 0. Again, you repeat the same until you get all the interrupts according to the parity. Did you understand? So this is what we are doing here. We are checking less than, this less than, get the highest parity value, and then get the highest parity peripheral. So once you get this, this is the one we have done. Finding the highest parity interrupt. This job we are currently out of 3, there are 1 we have done. Finding the highest priority interrupt. Once you get the highest priority interrupt, next what I need to do? Now you make interrupt value is equal to 1. Interrupt value is equal to 1. Then I need to give this question to the processor, right? So what I need to do? Interrupts to be, now I'm making this one. Interrupt value is equal to 1. Second one I have done. Now what is third one is? Give the highest priority peripheral to the one? Processor. How to give the highest priority to the processor is? Interrupt to be service. These are the interrupts. From the where? Interrupt to the processor is equal to what? Highest priority peripheral. Did you understand? Is it clear, these 3? This is a completely one from here to here. Used to find out the highest priority. Are you understand? And this is the one making the valid is equal to. Then giving the interrupts to the what? Processor. So once you do this, what is my next state? Once you do this, I need to go to the what? Next state. What is my next state is? Service to be done. Once I give questions to the finder or interrupts to the processor, what I should do? Interrupt given, waiting for the what? Service. Now processor should give the service. Then it is giving the service signal to the what? Interrupt controller. So after finding the highest priority peripheral, move to the next state is nothing but servicing is done, or this state also I can call it as what? I have given the question to answer. Then I'm waiting for the what? Your acknowledgement. Do you understand this? Now this is the one. In this state, in the next state, what we are doing? The last state, coming to this last state, what we are doing? Once service is done, we are making what? Interrupt validity is equal to 0. And after answering to all the questions, we are making what? IS parity peripheral is equal to 0. So this is what we are doing. So we are taking if interrupt service is equal to 1. If interrupt service is equal to 1 means it is giving the acknowledgement to the what? Interrupt controller, right? That means it is giving 1 means it has to answer all the questions, correct? All the interrupts should be addressed. Then what it should be addressed? Valid is equal to what? 0. Did you understand? Once all the interrupts will be addressed, this is indicating that this is interrupt service is equal to 1, indicating that it is all the interrupts are addressed. How do you understand? That signal is giving to the what? Interrupt controller. 1 is giving to the interrupt controller. How do you understand? From the processor to the interrupt controller, this is a signal, right? This is a signal. This is an input signal. If this is 1 indicates what? All interrupts are what? Addressed. Then I should make valid is equal to what? 0. Correct? This is what we are. Valid interrupt to be serviced what? That is also 0. And then IS peripheral is equal to what? 0. Then also IS parity value is also what? 0. Did you understand? So you make all this to what? 0. Is it clear? Are you understanding this? So after doing this, if interrupt control is equal to 1, I'm doing all this. If this is also 1, now I'm checking if any interrupts are there. Not is equal to 0 means what? If there are interrupts are there. If there are interrupts are there, what I need to do? Go to the next active state. Active state. This one. If there are interrupts are there, where I'm going? I'm going to the what? Active state. Again, there are interrupts are there, it has to do the same thing. All three things it has to do. Finding the IS parity, making valid, and give the IS parity interrupts to peripheral or interrupts to processor. So this is what it is doing. If active interrupt is not is equal to 0, next step it is going to 1. Then I'm making flag to 1. Making flag to 1. And or else what I need to do? If there are no interrupts, go to the 1. No interrupts. That's what I'm doing. This is nothing but next state is nothing but state with what? No interrupts. Are you understanding this? Is it clear now? Any questions here? Now this is the state type. 3 states we are representing. After representing this 3 state, what I need to do? I need to assign next state is equal to always and the next state is equal to what? State is equal to the next state. This is for what? State diagram, right? For how to get the next state value. State value is nothing but always at the next state is equal to state is equal to the next state. So this is your complete design file of your interrupt control. First we are doing the memory value. Memory module. This is your memory module, and this is nothing but what? Your interrupt controller. First interrupt controller state what it is going to do. First interrupt controller state what it is going to do. Take there are interrupts are there, go to the active state. No interrupts are there, state remains in the same state. The state with the active interrupts, find out the highest priority, make valid is equal to 1. Give these interrupts to the processor. So wait for the service, wait to be service. Then done in the service, done is the state what it is going to define. Valid is equal to 0. And then interrupt service is equal to 0. Correct? 1. It should be 1. It should be 1, right? This 1 indicates what? If this is 1 indicates I have answered all the questions. Peripherals is equal to 0. Then hash parity value is equal to 0. Interrupt to be serviced also what? 0. Then valid is also this state, in this state. This interrupt service of I is indicating one, all questions are addressed. But giving acknowledgement giving to the what? Interrupt controller. This one indicates what it is going to define. Questions are answered. All questions. So you can see here all questions, right? I'm making 0 means what? All questions. Once all questions are surveyed, giving what? Interrupt service is equal to 1. That indicates 1. Then we are making valid is equal to 0. All this we will be making to 0. If there are interrupts are there, still interrupts are there, go to the next state, RPU state. Else go to the what? Interrupt state with the no interrupts. Did you understand? Now we should write the design file to this. Now this complete interrupt operation is written in the design file. Now we are taking care about the processor, how processor will take the questions, okay, then addressing, then giving interrupt to service to the interrupt controller. We'll be writing those things in the way test events. And also how interrupts actives are generated, that is also we are doing in the way test events. The model we are doing in the design file is for one interrupt controller. Now looking at this, the test events what we written yesterday. Same, we are including the interrupt, then all parameters. I think the inputs are H type, outputs are Y type. I think no need of explaining this. Okay. Then we are instantiating and doing the 4x connection. Now we are generating the clock here. This is from here we need to start. Initial begin. First, since I'm writing the clock like this, always hash by T clock is equal to not of T clock. Then I should make clock to 1. Instead of clock to 0. Then preset is equal to 1. If preset is equal to 1, what is the operation? What is preset is equal to 1? What is the operation? All range data types to 1? Zeros. All range data types to zeros. So let me talk this a bit later. Now we'll understand. So after preset is equal to 1, we are introducing the delay. Then we are making preset is equal to 0. Preset is equal to 0. First, what I need to do? First, what we need to do? First, we need to write the what? Write some values to the what? Register. So for that, I'm using for write operation. For the write operation, so we're writing a task. We're writing the task. Task write. These are the arguments we are passing to the what? Write. What is the argument I'm using is address. Another argument is nothing but priority underscore data. So what I'm doing always at the positive edge of the clock. If P write is equal to 1, P control signal, if it is equal to 1, what I need to do? Write operation. P address of I is equal to what I'm passing here. Address. Vector of this what? Priority underscore data is also what? 3 down to 0. Now P address of I is equal to what? Address. PW data is equal to what I'm doing. This I'm passing. Priority underscore data. Then what I need to do the handchecking, P enable is equal to 1, wait, and P ready is equal to 1. Did you understand? Are you understand this part of program for the write operation? This is what you've done in the way, memory modeling, right? So after always positive edge of the clock, now what I'm doing? After doing this, for all the locations, what I'm doing, next if clock edge comes, I'm making all these things to what? Zeros. Make all these to zeros. This is nothing but a write operation task. Write operation task. This I am calling here. This task is calling here. This task is calling for what are the locations is for? I is equal to 0 to the 1. I depth, then I plus plus begin. I'm calling this. Did you understand? This is a write operation. Write operation to the what? Write operation to the what? Priority register. Write operation to the priority register. Then after writing write operation, what I need to do? Interrupts. This is what? This is what coming from the web peripherals, right? Interrupt underscore active. So we're generating the what? Random interrupts. Random interrupt. Then we give the same time and then we'll finish this. Did you understand? Then what is a processor modeling? Is imagine what is a processor operation? Takes the interrupts from the what? Interrupt controller. Then what it has to do? Service. Do the service to that. Correct. Do the service to that. Then what we need to do? It is giving the one signal to the what? Interrupt controller. Interrupt to be serviced means what? No. What it indicates? Interrupt to be serviced means what? Questions. If it is not is equal to 0, means what it defines here? There are questions. There are questions. There are questions. What I am doing? I am giving some delay. Okay, immediately I can't give. So that I will give some delay. Now what I need to do after getting the questions from the interrupt controller processor, it should address, right? So interrupt underscore RQ of interrupt to be service is equal to 0. I am giving what? Service. Here it is giving the service. Once I am giving the service, what I need to do? Interrupt service is equal to 1. This is what? Serviced. Questions are answered. Correct. Then after some delay, what I'm doing? Again, I'm making what? Interrupt service is equal to 0. Means I'm waiting. I'm making 0. If there is a questions, give me, I'll service. Then I'm going to make what? Interrupt service is equal to 1. Saying that I have addressed. So this is a job of the what? This is a job of the processor modeling. Processor modeling. So this modeling we have done in the test bench or in design file? Design. Processor modeling is we have done in the design file. Correct. And then this is nothing but what? Your peripheral modeling. Interrupts are generated where? Random interrupts are generated in the test bench. Correct. Now this is a processor modeling. Now here, after making preset is equal to 1, I am taking reset. I am calling one task here. The task name is what? Reset. What is this reset task? It defines that all the input variables, these are tasks we are writing for the reset. Task reset, begin. What I am doing, you can clearly see what we are doing in this reset task. Some sort of making all the inputs to what? Zeros. All the inputs I'm making what? Zeros. Did you understand? If you're not using this reset here, what happens by default, it will take what? X value. All these signals, what are the signals I'm using here? By default, when preset is equal to 1, it will take what value? Unknown, X value. Because since these are declaring as a range data type, its default value is nothing but what X. To avoid that, what we are doing is nothing but we are writing the resetted task. The resetted task, we are making all the inputs to making to 0. You can understand. This I am calling after preset is equal to 1. I'm introducing the delay, then preset making to 0. Now this is what? Write the register, priority register. Now this is the interrupts coming from the peripherals. Did you understand? And this is the what? Processor modeling. This is a processor modeling. This is a processor modeling. Then this is for what? What is this? Is nothing more. Resetted task. This is for what? Right after. That's it. Did you understand? Now I'm doing only first one I'm doing. I'm writing, let us write I comma I. So these are the arguments I'm passing to the what? Write a task. So I comma I. Now it is going to call this task. Correct. I comma I, it is going to call this task. So what happens here? 0 to 15. Because this address I'm passing as what? I. And this parity underscore data is also what? Passing what? I, right? I means what? This is also takes what? 0 to 15. This also takes what? 0 to 15. 0 to 15. Are you understand? Now let us run this program. Let us make all this into unsigned format first. First, we have done the what operation? Right up. Let us take this a right operation. This is a right operation. I think this is not saved. This is running for. Let us open these test events. I have changed this into the what? Let's make a replace this I by I. Save all. You can rerun this code. Now you can see, let us make all this into the unsigned. Let us understand this. This is my P address. P address is what? I'm passing I value. I is not one. 0, 1, 2, 3, 4 up to 16. Then priority data is also what? Same. This is nothing but I can call lower order values will get what? Lower values. Lower order value gets what? Lower values. You to understand. This is nothing but T address. This is nothing but what? T, right? We are writing the priority register. Priority register. Now what I want to do, you can see this is my what? Interrupt underscore active I. This is my interrupt underscore active I. Active I. Now you can see how many interrupts are there. Means how many persons are there? 0 to 15. 16 persons are there. In this 16%, let us keep the cursor here. Let us keep the cursor here. Who are interrupts are raised here? You can see what the interrupts is raised is 13, 12, 10, 8, 8, 5, 2. 2. Correct. Now we need to what? Address this. We need to address this. Now you can see here what are the interrupts are raised is 2, 5, 8. Correct. Then you can note on this 13, 12, 10, 8, correct? 8, again 5, 2. Means here these are 2, 5, 8, 10, 12, and 13. According to this, the priority register, which one we need to serve first? 13. So I served the 13. Then what I do? I need to make this what? 0. Now next which one I need to give the service? 11 or 12? 12 is raise the question. Now let us keep here. If I keep here, you can see 13, 12. This is one first it is served. Yes. Go in. Let us keep the cursor here. First it is served what? Highest priority peripheral is nothing but what here? 13. Correct? Now you can see this 13 flag is 1, 12 flag is 1, then 10, 8, 5, 1, 2. First, among this, which one I need to serve? 13. What is this 13604 here? What is this? Is nothing but what is this 13604 here? It is value of this is nothing but 001100100100100 is nothing but what? Its equivalent decimal number is nothing but 13604. You understand? We need to give the service to the what? 13 now. Then which we need to give the service? Which one we need to give the service is 12. Now you can say this is 12. Now we are giving service to the what? 12. Now we are making 13 to what? 0. This is Sarul. Correct. Now it is going to what? 12. The equivalent value of this 0, 0, 1, 1, 1, 0, so on. Its value is nothing but what? 5, 4, 1, 2. Did you understand? The next way is what? What is next is? Next, I need to give service to the what? 10. Now you can keep 10. Now this is a service is 10. Next service is 10. Are you understand? What its value is nothing but 1316. Now this is the one we are serving. So after serving this makes to what? 0. So the next is what I need to service is nothing but 8. This is 8 it is service with highest peripheral here. You can see highest peripheral, highest parity peripheral is nothing but this is the one. Correct? 8. So what? 5. Did you understand? After this, what I need to service? 2. It is serviced according to the what? Parity. Did you understand? This is my right operation. Correct. Right operation. There is no read operation right here. I don't need read operation. I want to write to the what? Register, a priority register. Then I should take care about what? Interrupt controller operation. So you make among which one is highest parity, you keep it first, and then you keep it second, so on. Then after that, I need to serve to the what? Processor. Are you understand? Now, what we can give the name to this is nothing but lower order peripheral gets the what? Lower values. Here, higher is nothing but higher. 0, 1, 2, 3 is nothing but lower peripheral values. Lower peripherals gets the what? Lower values. Higher peripheral gets what? Higher values. I can consider this is a one test case. Lower peripheral will get what? Lower values. Now, how to make lower will get the higher values? Second test case I should analyze. Correct. Lower peripheral gets the what? Highest value. Highest value. What changes I need to do in this program? I think now did you understand this timing diagram of this? Are you understanding? Okay. Now let us go to the next one. The next one, what I need to do? Lower peripheral gets what? Higher value. What changes I want to? I comma, what I want to do? Shall I make a depth? Depth is what? 16. 16 minus I means what? When I becomes a 0, 16 minus 0. Okay. 16 minus 0 means what? 16. Again, what I can do? Minus 1. If I is equal to 0, depth is 16. 16 minus 0 is 16. Again, 16 minus 1 is nothing but 15. For I is equal to 0, now it is getting the highest value. 0 will get what? 15. 1 will get what? 14. 2 will get what? 13. So on. Did you understand this? Now what I am making, lower peripherals will get the what? Higher value. Are you understand? Now let us save this. Save this and run this. Now, can you understand this? Understand this timing diagram? 0 gets what now? Okay. 1 gets what? 2 gets what? So that lower peripheral gets what? Higher value. Now, you tell me which one it is served now, this case? Which one it is served now? Now, earlier case, what are the raised interrupt raised is 13, 12, 10, 8, 5, 2. First, we will see what are the interrupts are raised here. What are the interrupts are raised here? So, how to take this value? This is the one. Right now, all these flags are what? All these are interrupt raised by 0, 0, 0. Now, first it has to do service to the what? 2, right? Because 2 gets what? Highest value. Then what it has to serve? 5. Then what it has to serve? 8. According to the previous case, what are the interrupt raised is 1. I'm talking about. Same values I'm getting. Same values I'm taking. You can see here. Here, first it is serving what? You can see highest peripheral priority is what? 2. Next it is what it is serving is 5. Next it is what? 8. Next it is nothing but what? 10. 12. Next is what? 13. Did you understand? Are you clear? Now let us keep the cursor here. 2. Now see, these are the flags rise list. 13 is 1, 12 is 1, 10 is 1, 8 is 1, 5 is 1, then 2 is what? 1. Because I'm using double symbol random, this will generate the same set of every time you keep running many times, it will give the same set of values. Like if you want to get the different, what I need to do? What I need to do? Then I can go for the what? Seed include. Include the seed. You can understand? Now once this is served, 2 is served, now I should make to what? This is to 0. Now next what it is going to service? Next is 5. Now see, we are making this 2 to what? 0. Then it is going to serve what? 5. After 5, next is 8. Then next is what? 10. Next is what? 12 and next is 13. Lowest peripheral gets what? Highest value. Did you understand this? Second test cases. Are you clear? Now what I am going to do, what is another test case you can think of to do here? Then you make all the peripherals to what? Let us keep some random value. Let us keep 5 or 10, whatever the value. Did you understand? In that case, which one is to be served first? Now here the flag is interrupt raised is 13, 12. Okay, then 13, 12, 10, 8, 5, 1, 2. If my all peripherals will be the same value, common value, then which one it has to serve first? Is it 13 or it is 2? Is it 13 or 2? So let us make save all. Save all. Now let us run this program on the next. Now you can see all these are what? Same 5 only. First, what it is going to serve? 2 or 13. All are the same value, right? Common value. So this constant flag at 2 is equal to 5. This will be served here. 2. Then what? 5. Then 8, 10. Then 8, 10. 12, 1, 30. 12, 1, 30. Did you understand? If all are what? Same. Same condition. Now you can also do one more test case. One more test case. So what are the test cases we are running? As of now, we are running the 3 test cases. One, lower peripheral gives the lower values. Higher peripheral gives the higher values. Correct. Then we did lower with the highest peripherals with the lowest. 2 test case, and one test case is nothing but what? Same value. Same value. Now what you can do? This is also covers the same. Suppose if 2, let us take, in this, the values are 2 values are common. Suppose these are also 5. Let us make this is also 5. What happens in this case? First it is given to the 2 or it is given to the 5. Now it is first come first service, right? Now this comes what? This is what exactly happened here also. Since this is 2, what is first come first serve? Since all are common here. All are same usage. First come first. First is 2 is 5, then 5 is 5, then 8 is 5, then 10 is 5, then 12 is 5, and 13 is 5. Did you understand? How do you understand? This is the third test case you can think of. Now, what is the another test case you can do? Any other test case you can able to do? Any other test case you can able to do? Random. So randomly you generate these values. You understand? Randomly you generate these values. What values you can generate is nothing but unique random values. What is the unique random values? No repetition, right? It should fall between 0 to 50, but there is no repetition. Value should not repeat. Now, how to do this? How to do this? I think we have done this same thing. You know how to assign the value to the array, right? Loop in the loop. Nested loop. Nested for loop. I can assign the what? Random value to the what? Array. I can use that, right? When I can use the nested loop for in the for, but I need to check the condition. What condition I need to check? I should generate the what value is random values, but unique to random value. The number should not what? Repeat. So this sort of program already you have done, right? How to assign the values to the array you have done. Loop in the loop. Loop in the loop. Along with the additional logic what you need to incorporate. Check that whether if the same value is there, you skip that. You can assign the next value. If next value are also matching, then what you need to do? Skip that. Did you understand? So let me explain that. What is the random? How to do the random? Last test case is nothing but random test case. So what is a random test case is nothing but we are writing the task for this. Task for this random. So name is nothing but name of this task is nothing but random. So what are the variables is required? We declared here. Range random flag is required. So this is one variable we declared here and value k comma n. These are variables, integer variables we are using here. Now you can see here begin. I'm using the two loops, two for loops. Here one for loop and here another for loop. In this for loop is iterating k to 0, k less than or k less than 10. Comma k is equal to k plus 1 increment also. So what I'm doing in this case is nothing but first I'm taking the value. What is the value I'm taking? Unsigned range from what? 0 to 15. 0 to 15. Then I'm setting flag to what? 0, assuming value is not available in my array. Assuming that initially there is no value available in my array. Again, I'm taking the one more for loop, nested loop. This is one loop, for loop. This is another for loop. Now what I'm doing here? This for loop, if parity array of L means if L becomes 0 is equal to what? Value begin. What I'm doing here? Making flag to 1. This indicates that value is available in my array. Now assigning the value, right? This tells that the value is available in the my array. Then once the value is flag is equal to 1, it indicates that value is available in my array. Then what I'm doing? I'm checking with what? L is equal to K. If this is equal, if flag becomes 1, if L is equal to K, I am skip this iteration. Skip this iteration. Again, what I'm doing? Flag is equal to 0. Else flag is equal to 0. If this is equal, exit this loop and coming to the what? Flag is equal to 0. Random flag is equal to 0. Here, if flag is equal to 0, what I'm doing? If flag is equal to 0, what I'm doing here is priority underscore array. This is declaring as a variable of k, then we are assigning the value. Assigning the value, then increment the what? K. Increment the k. So from year to year, what it is going to check? Year to year, what it is going to check? If any values are what? Repeated, by setting this flag, we are checking. First, this tells that assume that there is no value in the available in the array. This tells that value is available in my array. If values are available in array, I'm checking if L is equal to K. If L is equal to K, what I'm doing? I'm making random flag to what? 0. If my random flag is equal to 0, then I'm assigning this priority underscore array. I'm assigning to the what? Value. Then I'm going to increment this. So this is what exactly we have done. Assigning the value to the array, right? Loop in the loop. Correct? But here we are checking one more condition is that if it is equal, then we are coming out of the loop. Are you understand? Then we are assigning the value. Is it clear? Okay. Now this random task is calling in. Random task is calling in. So we are making the case statement here to run the what? Different cases. So for how many cases we have done this? Test low peripheral with what? Low priority. Let's test what? Low peripheral with what? Highest priority. And the test all peripheral with what? Same priority. This is nothing but I, I. Low with low is nothing but what? I, I. Low with I priority is nothing but what? I, depth minus I minus 1. So test all the peripheral with the same priority is nothing but what? I'm giving the what? Pi is common to what? All the peripherals. These are 3 test cases just now we saw. Right. Now I'm putting this into the what? Case statement. Then I'm using what? Dollar symbol value plus dollar symbol answer for the argument during the runtime. During the runtime. Now I need to declare this variable. Right. To declare this variable, I can use the what? Reg 500 or some value 500 to 0 and test the case. You can understand? Now, first case is the first case, this is second case, this is a third case, we understand. Now coming to this random test case. Random test case. The random test case I'm calling here. Random. Random task is calling here. This is one. This one calling here. This random task is calling here. Did you understand? Now I want to print what is the index and what is the priority value to check that whether it is generating the unique random value. So just I'm printing the what? Index and the priority value. That's it. For taking for m is equal to 0, m is less than that, m is equal to m plus 1 to print this. What are its index value? What are the parity values? Are you understand? Next, what I'm doing? Same thing. I'm using this part for I is equal to 0, I is less than depth, I plus 1. Then what I'm doing here? Right? I comma, here I'm going to assign the what? Parity, unique priority values. So parity underscore array of I. So this is the test case for what? Random test case. Random test case. Now we'll run this random test case. So what exactly I have done is but all these 3 cases, all these 4 cases are implemented in the one case statement. These things already you know how to do. In previous projects, we have worked on this, right? We have worked on this in previous projects, in memory project. Correct? Memory project, and even in synchronous FIFO, asynchronous FIFO, we know it. That's why I'm just explaining this one. Now we understand this test case, we understand this test case, we understand this test case. Now let us go for random, unique random generation. Okay. Now let us run this program. After this, you end this case, then interrupt underscore active I is equal to what? Dollar symbol random. Then just I'm printing these values. Then finish. Then this is for what? Same modeling for what? Processor modeling. This for task for what? This is task. This is a task for what? Right task. We are not using read task, right? Read task is not necessary. Line number. This is that. Just I'm saying that I want to print the index value and the practical value. So for that, I'm using this formula. You can avoid this also, there is no issue. To bring this in the console, I'm writing this loop. What are the index value? What is the parity value? So I'm using this loop here. If you're not using also, there is no problem. It is not going to print the index and parity value at the what? Transcript. Did you understand? So this is for reset task, and this is for write task, and this is for random task. This is for the random task. Did you understand? Now let us run which task? Let us run the random task. Okay, let us run now. One by one. You'll understand. So this is a task. What is this task is? We are testing low peripheral with the what? Low priority. So what I need to do? I need to pass the what? Argument. This is a tb1.v. Okay. Then here I need to pass this. This is one first I'm checking with test low peripheral with the what? Low priority. Let us say one run this code. Let us comment this. Yes. Pass the argument during the run. Let us say this. You show that TB1 can't open the interrupt controller. So given the name as user name as interrupt, not interrupt controller. Let us remove this. Now can you check this? Let's make all this into unsigned. Unsigned. Lowest will get what? Lower value. Correct? Lowest will get lowest value. So then what is the value it is serving here? It is 13, 12, correct? 10, 8, 5, 2, so on. These are one test case. What is the second test case? Second test case is nothing but test low peripheral with what? Highest priority. So what I want to do here is nothing but instead of low, I should make this into what? Highest. Highest. Correct? This is a name. Let us take this. High priority. This is not highest. High priority. Does make this into same power. Now low get what? Highest priority. Now you can see. Now it is 2, 5, 8, 10, 12, 1, 13. It is served to this one. Are you clear? And what is the next is? Let us check with the next is same priority. Test all the peripheral with the what? Same word. Let's come. All with the same parity. Let us run. So all are with same. So how it is serving now? 2, 5, correct? 2, 5, 8, 10, 12, 13, so on. Now last one is test the random pattern. Test the random pattern. This is what I'm using for loop, right? So I'm printing the what index and what parity value. These are the parity values. Which is the highest parity value for this is nothing but index 14. What are the priorities raised here? What are the priorities are raised here? 13, 12, 10, 8, 5, 1, 2. Now, which one it is going to serve here? 13 will get 13. Now you can see this is the one I need to check. 13, correct? 12. Next is what? 10. Next is what? 10, 8, right? 8 is 1. 5 is 0. 2 is 8. 2 is 8. Now you tell me which one it is going to serve. Now see here, this is randomly generated here. This is the RQ interrupts here. 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. Since I'm using this to print here, I'm printing this value. Did you understand? Now can you go to the waveform and understand which one will be solved here? Let us make all this into the unsigned. Unsigned, this is randomly, it is assigned. Not with lowest with the highest with the lowest are same. Now 0 gets what? 7. Correct? Let us check the transcript. 0 get what? 7. 1 gets what? 12. So 2 index gets what? 8, so on. This is what it is getting. 7, 12, 8, 6, 4, 9, 11. Correct. 1, 0 it is randomly, it is getting the values. Now, which one it is going to serve? To check this, what I need to do? Which one it is going to serve? It is nothing but first it is serving 13. Because 13 is raised, interrupt is raised here. Correct? 13 is raised here. Let us go to here. Here, the 13 is 1, raised here. It is 1. 13 index value, this index 13, its parity value is what? 13. First it is serving 1. Correct? Next, which one it is going to serve? Now, first you understand here. 13 is 1, 12 is 1, 10 is 1, 8 is 1, 5 is 1, and then what? 2 is 1. 2 is 1. Now you tell me which one it is going to serve. First is 13. After 13, 2 it is going to serve. Next, which one it is going to serve? Okay. Yes. So, okay, let us write it here. 13, right? 13, 12, 10, 8. Next what? 5, 1, 2. What are its values, sir? 13 is 13. Correct. You can write here. 13 is 13. 12 is what? 12 is 3. 12 is 3. Next is what? 10 is what? 5. Next 8 is what? 8 is 1. 5 is 0. Then 2 is what? 8. Is it 2 is? Yeah, 8. Now you tell me which one it will be served first. 13. First it will serve, correct? 13. Next what? 2. 10. 12. 8. 5. Correct? This will be served here. First is 13, 2, 10, 12, 8, and 5. 5 and 0. Did you understand this? This is nothing but what? Random parity. What other things you can do here? What other things you can do is you can include the seed to the random. That will generate a different interrupts rising. Okay. Additional things what you can take up for this one. Include the seed and check the lowest with the lowest, highest with the lowest, same, and then random parity. Are you understand? And here I'm repeating only one time disease. Correct? You can repeat one more time. Check how it is serving. Okay. Repeat one more time disease. Repeat one more time. Check how it is serving. Are you understand? These things you can take up an assignment. Include the seed value. Check the all these test cases. Then here I'm repeating only one time disease. One time it is. You repeat after some delay. You repeat one more time. You check what is your priority register. What are the according to the priority which one it is serving. Then you repeat one more time if you want. You check the priority register with which one it is serving. Did you understand? Are you clear? So this is about interrupt control. I hope you understand this. Okay, you try to do yourself and then understand the flow of interrupt control, how to do this interrupt control. Okay. So with this, we will stop this interrupt controller. The next session we'll go with the SPI control. Okay, first we'll understand the theoretical part of SPI controller. Then we start writing the little program. Is it clear? I'm leaving you 3 things to you to do. What is the first thing you need to do is include the seed. Include the seed and see the behavior of all the 4 test cases. Okay. And one more thing is nothing but you repeat this same. After some delay, you repeat this. You check whether it is serving as what. According to the priority, it is serving or not, you make it. Are you clear? You take up this as an assignment and do it. How to do this is, let me tell you. Now this is only the one priority I'm checking here, or one test case I'm checking here. What I want to do, yeah. Now if I want to repeat same, what I want to do. So after this, give some delay here. Hash 500. You copy the same. Copy the same. Correct? Sorry. Correct? Now this will repeat one time. And after some delay, I'm giving this. Are you clear? Then you check how it is assigning the priority, how it is selecting the priority for First this case and next this case. Are you clear? And one more thing is nothing but include the sleep with this to generate a different random values and check the output. Now, in this my case, it is generating 13, 12, correct, 10, 8, 5, 1, 2. You change that and see how it is assigning the plan. Are you clear? To take up this two as an assignment. Please let me stop the session here. The next session will continue with the SPL control. Okay, let me stop the session here. So we'll continue in the next session.